This is the video for 9.6 post test, which is space figures. This post test is a little bit more difficult. It's a lot of visualizing geometric shapes in 3D. So I've taken this a few times just to see other questions. So hopefully I will answer any questions we might have. If you have any additional questions, please email me, as this is the last post test of the marking period. The first question is asking about a plane region that revolves completely about a line that sweeps out a solid of revolution. Describe the solid revolution you get by revolving the region to the right about line L. So I'm starting with a triangle shape and I'm revolving it around this line. Okay, revolving it means I'm going to continually make a circle, okay, in 3D here. So I'm starting with a triangle and I know it's going to have some circle in it. So the only shape here that has a triangle and a circle involved is going to be a cone. Okay, some of the other questions I've gotten here is a semicircle, and if it's a semicircle that we keep revolving, that's going to make a sphere. Okay, so just keep that in mind. It's this shape within that additional circle, which is why mine's making a cone. Okay, this question's asking about cross-sectioning a cube for me to get a square. Okay, if I look at what's getting cross-sectioned here, if I cross-section this, okay, there's no way this is going to make a square. These are not equal sides. I'm not going to be able to cross-section here a square. And a cross-section here means I'm just going to basically cut out this yellow figure here and what I'm going to be left with. Okay, it's going to be a 2D figure that I'm left with. Okay, if I cross-section here, okay, this is definitely more of a rectangle that's getting cross-sectioned out. Okay, but this one here is actually going to be the square getting cross-sectioned out. One of the other questions here that I've gotten before is an isosceles triangle, and to cross-section that, obviously it won't be cubes, I don't believe, or it's on an angle, but it's going to be the rectangular looking one to get an isosceles triangle. Okay, but this one's for the square. Okay, this one is another cross-section question. We have this figure, and it's asking us for the horizontal cross-section. And again, it's kind of what this little shape here is if I were to horizontally, left and right, kind of cut out a piece here in the middle. One thing to note here is that the shape is hollow. Okay, it has a little circle here that's open at the top. So if I were to cross-section this left and right, I'm going to have that open circle in it. Okay, if I look at my choices, the only one that's going to have that open circle is this choice D. Part B is asking the vertical cross-section. Okay, right through the vertical line of symmetry. Okay, so if I draw a vertical line here that's symmetrical, it's going to be here. If you notice, it goes right through this hollow circle here, which means that cross-section is going to have a big gap in the middle of it. Okay, and that's what my choice A is doing. It has a gap in the middle, and I'm going to just have two rectangles on either side. Okay, this one we have a tetrahedron, and we need to name the vertices, the edges, the faces, and then some intersections. Okay, a vertex here is just where two edges meet. Okay, basically it's where these four letters are. So those are my four vertices. It says use a comma to separate, so I'm just typing out my four vertices. I have B, L, G, and K. The edges are what connect two vertices. So I'm going to be very careful that I type these correctly. I'm going to first go on the outsides. So first I have this edge, BL. Okay, that's from this vertex to this vertex, BL. Then I have LG. That's this edge. Then I have GK. And then I have KB. Okay, that kind of goes around. BL, LG, GK, KB. Then I also have this edge here, LK. And I have this edge here, BG. So there should be 1, 2, 3, 4, 5, 6. There should be 6 edges in total. Next, I have faces. Faces are the faces here of the figure. They make, in this case, triangles. So it's all these triangle faces. The first triangle face I have here is BLK. BLK makes that face. Then I have this face here, KLG, or LKG, or GLK. Okay, there's a lot of different names we can call this face. I'm going to call it LKG. Okay, so I have this face, and I have this face. Those are kind of the two faces I'd be able to see if this 3D shape was in front of me. And then I have a face that would be facing the opposite direction of me, so I actually wouldn't really see it, but it's this face here, BLG. And then I have the face at the bottom that's in this dark gray, BKG. So there are 4 faces to this figure. Okay, the next question is asking about an intersection of a face and an edge. So the face LKG, which is this face, and the edge BG, which is this edge here. LKG and BG edge intersect at what? LKG and BG? Well, they're going to intersect at this vertex here, G. And then I have the face LKG and the face LBK. LKG and LBK, it's this face and this face, they intersect at an edge that they share. In this case, it's the edge LK that they share. Again, I've taken this post test a few different times. I believe every time I've taken it, it's been the same answers. So keep that in mind. Hopefully everyone's letters are the same and you can relate it to your own question for this one. Okay, this next one is to just identify the solid. Okay, this just goes back to some previous knowledge of some 3D shapes. Okay, this one here for me is a rectangular solid. Okay, it's not a cube because not all the sides are the same. Clearly not a sphere or a cylinder or a cone or a pyramid. If you're unsure what yours is, just do a quick Google search to refresh on some of these shapes. Okay, this one, I've actually gotten a different question every time I've done this one. The key here with this one is just knowing what the base shape is. Okay, what I mean by that is the base here is this 1, 2, 3, 4. It's a quadrilateral base. Okay, it is not a cube in this case. A cube would, or this truncated cube, it would actually look like a cube with like one face being a little bit off. Okay, this one is not a cube. This one for me would be a quadratic prism. Okay, it's definitely not a pyramid and it's not a pentagon because again the base here is still a quadrilateral, which makes the quadratic, that quad prefix. Okay, this question is asking about the vertices, faces, and edges to this polygon, or to this polyhedron, excuse me. Okay, so again, the first thing is asking about vertices. If you look at the choices, it's either 8 or 7. So if I count it, 1, 2, 3, 4, 5, 6, 7, 8, there are 8 of them. So I know it's either my choice A or choice C. And now I just have to go through and make sure that they're all there. Okay, the choice that it's not, there's going to be an extra letter or a letter that's not in there. So I'm just going to double check. I'm going to look at my choice A that has the 8 vertices and just double check. So I have Q, I have R, I have C, I have L, I have E, I have F, I have G, I have H. So it is my choice A. They're all there. If I go to the other one with 8, there's going to be a letter in there that's not there. It looks like it's this Z. This letter Z is not a vertex of my figure. Okay, next question is asking how many edges. If I look at the choices, it's either 9 or it's 12. If I just count it real quick, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there are 12 of them. And again, there are two choices that are 12, so one of them is not going to be an edge. So if I look at my choice C, the first edge that's listed is QH. So if I look, here's Q, and here is H. That is not an edge. They are not connected in any way, so I know it cannot be my choice C. It has to be my choice D. And then the next question is asking how many faces there are, either 3 faces or 6 faces. Okay, there are going to be 6 faces here. We have 1, 2, 3, 4, 5, 6 behind it. Okay, there are 6 faces. Of the two choices that say 6 faces, you have to be very careful. When you name a face, okay, I'm just going to look at my choice C first. When you name a face, the edges have to be connected. So if I look at this first one, QRFE, QRFE, those edges are all connected. Q to R to F to E, those edges are connected. But if I look at my choice D with the first 4, I have QFRE. If I look at that face, it's Q and then F. You see how Q and F do not connect? There is no edge to connect them. That's how I know it is not my choice D and it is my choice C, where they are all connected edges. Okay, this question, the figure on the right represents a card attached to a wire. Determine what the figure would look like if the card were revolved around the wire. Again, we're talking about revolving, which means we're going to have a circle involved in some way. So if I look at my choice A and my choice B, there is no circle. Again, I'm revolving. I need some sort of circle. Okay, choice C and choice D both have some sort of circle involved. Choice C is a cylinder, and choice D is kind of 2 cones connected together. Okay, if I think about what shape I'm starting with, and if I make these circles, it's going to make those 2 cones. Okay, very similar to what B is, but B does not have the circle. D does. Okay, so it's going to be my choice D, making these kind of 2 cones. Again, because we are revolving, it's going to make a circle. There's going to be a circle involved. Okay, this question's asking to name the polyhedron that can be constructed. So it's kind of like if I have this base, okay, in this case my base looks like a square, and I kind of fold up all of those triangular pieces on the outside, what shape it will make. Okay, so the key here is to identify what is your base. Okay, of my choices, my base is clearly a square. Okay, here's the square. So you could have hexagon, you could have a pentagon, you could have a rectangle. Okay, there were several other bases that I had when I did this question before. For mine, my base is now a square. So that eliminates the hexagon and the pentagon. So that leaves either a right square prism or a right square pyramid. And here you just have to decide what's kind of happening. If I were to fold up all 4 of these triangular pieces and connect them, it's going to make a pyramid for me. So this one is going to be a right square pyramid. Okay. This kind of goes with this last question of naming this 3-dimensional figure. Okay. It's if you look at what my base is here, again, it's this square on either side. So if you notice with all three of these choices, I have this kind of square here on the edge, and all my faces are these rectangles. To figure out what the correct shape is going to be here, you have to count your faces. Okay, the faces of this figure. So I'm going to be very careful when I count this. I have this face here that's kind of facing me, so that's 1. I have the face on top, which is 2. I have this face that would be kind of on the left side. Okay, that's 3. And then I have the face that's on the bottom that's resting on, so that's 4. So this one actually has 4 faces. Again, 1, 2, 3, and 4. So I need 4 of those rectangles, which leaves me with choice A, 1, 2, 3, 4. This one only has 3 faces, and this one has 5 faces. Okay, so be very careful when you're doing this post-test. This post-test, again, is a little bit more difficult. If you have any questions, please email me or comment in Google Classroom. And this is, again, the last post-test of Marking Period 3. So all of Module 8 and from 9.1 to 9.6 should be completed. Again, please email me with any questions.